So today we're going to deploy an Express web application. The goal today is not so much to teach you how to programming, as that really can't be summed up in an hour, but just to give a gross overview of what we go through in order to deploy the application. So instead of typing out the code, I'm just going to copy and paste it just for expediency. Now, while web applications are not what you would call traditional HPC, as we move forward in the world, more and more things are online and more things are visually displayed. And I get a lot of questions from researchers on, I want to put my code, or I want to put my application on the web. How do I go about doing that? So I've talked in the past about how to start up a cloud instance and how to connect your code, how to set things up on there. But what I've always seemed to have skipped is how to actually physically deploy a web server with an application. And that's what we're going to cover today. So if you want to see an overview of the cloud, it is also on our SharkNet YouTube channel, as well as I've got a terminology webinar I did last time on what some of the words are we're using. Today we won't get into that. Today we're just going to do the deployment. So without further ado, so what we're going to do is we're going to do it in two parts. We've got the server side and the client side, and it's a chicken and an egg situation. Is you got to put the pieces together to get it to work. So the server side, we're going to use Node.js. It is a very popular package that uses JavaScript, it uses ECMA code to write the back end. And if you've ever, it's the same as Apache or the same as Nginx for deploying it. We're going to use the Express package. It's just a deployment package that makes things a lot easier to deploy a web server in Node. And also on the server side, more of an aside, we're going to use MySQL for the persistent data. On the client side, we're going to use something called EJS. And EJS is simply a server-side page builder, basically. It's the same. If you've ever used PHP, it does the same thing. Is it sends the rendered page to the client as opposed to getting data back and forth. And it just generates HTML. We're going to touch on that very lightly. SCSS is a better markup. It's a superset of the CSS language. That makes for transpiling CSS pages a lot easier to read, and you can add variables and stuff. Again, we'll show you how to deploy that in Node, less on how to use that. But the deployment, there's a lot of nuance to CSS sheets. Thirdly, on the client side, we call it ECMA. So I'm going to be using a module system as opposed to old-fashioned JavaScript. And that is simply means I'm going to be using modern JavaScript or ECMA code on the client side. So quickly, a review of what we're going to build. We're going to build a very quick and simple CRUD API. We're going to call it the inventory API. Now, CRUD stands for create, retrieve, update, delete, and those are the operations we're going to build. And that means that the HTTP method, anyone who's done any web programming will be familiar with the get and post methods, but there's also a couple of others we'll be using put and delete, and those will be a way of telling our API syntactically what the operation is we want to do. I've got a body here, so this is additional information parameters that we send on the CRUD request. And I've gone with two different ones here, and that's more for a demonstration purpose than any real reason. And one of them is going to use a URL, which is URL encoded, which is the way that HTML forms send their information. And the other ones are going to use JSON. We're just going to put a JSON object into the body of the HTTP request. DBI is short for database interface, and I just like to stick this on my CRUD description so that when I'm coding it, I can go back and refer to it, what actual software methods I'm calling that do the database, the data, the model retrieval. And you'll see that momentarily. So this is not a slide-heavy presentation, and that is it for the slides. And we're now going to just start to deploy our web app. So we're going to start here with the terminal. And we're going to start with a empty directory. So we'll just make directory our demo app and call into our demo app. Now there's nothing here yet. We're going to use what's called Node Package Manager. NPM has a series of commands. You can just press NPM enter to get the list of them. But what we want right now is NPM init, and this will initialize a new project to use the Node Package Manager. The demo name is fine. I like to start with a 0 version number when I'm developing. We can add that later. So the default entry point for an NPM app is index.js. We're going to go with source and app.js, and you'll see why in a moment. Don't worry about tests, don't worry about the Git repository, and so on and so forth. We can add all these in later. But what that does is it creates a file called package.json, which if we look at, has all of the default information that we just entered. We didn't enter a test app, so it didn't do any, but you can see that. The second thing we want to do is initialize a Git repository for it. So we just go git init, and now we have the .git file there, and that just helps things. We just do that right off the bat. We're going to create a git ignore file, and that is where we're going to put certain files that we don't want to be added to our repository. And now we're going to we're going to create a couple more directories. Source, you'll recognize that as our server-side source. Test, our server-side test files, and www, which is the public files that will get served by the web server. Sometimes it's called public, sometimes it's called www. Those are the things that the end user will see. Now we're going to open this up in Visual Studio Code. I've got a new one here. I'm using a WSL extension, and that is not necessary, but it does make it a little bit better for VS Code to communicate with Windows Subsystem for Linux, which is what we'll be running the server on. So let's go this file, open a folder. We'll open the folder we just created, which is called demo app, and there we go. And we will recognize all of the directories we just made, along with the git ignore and the package.json file. So the very first thing we're going to do is we are going to add node modules to the git ignore. And what node modules is that's where all of our packages are going to be stored. We're just going to save that. Now we're going to do a quick little aside, and we're going to set up. So I've already got MySQL running on my WSL, and typically you would actually have a third-party server that does this, but you can run it locally. That's not much of a problem. And we are going to add the user. So I have to be root to add the app user to it. And I'm just going to show you those two commands real quick. So you will go, I'm just going to show databases here just to make sure I've deleted the database from my tests. And we will go, let me open up my notes here. So the first thing we want to do is we want to create the user. And it's going to be local only. So the username has local host. It's not going to be accessed from outside of the server. And the identified by is just going to be the password that we use to access it. And then we have to create the database for inventory. So this is the database where the tables will be existing. Now we use inventory because we're going to create the table while we're in here. So create table inventory. The table called is inventory, so the database table have the same name. This field here is your primary key. We're never going to enter that, but we want the database to create that for us. So it's got auto increment and not null. And that will, every time we add a new record, it'll just add one. Description for our inventory app is a varchar. Quantity is an integer. And now you might be familiar with float from a lot of programming languages. We're going to use something called decimal, and that just gets rid of our floating point error and uses a decimal representation in SQL. The 10 and 2 mean a total of 10 digits, 2 of which are decimal. So we got one table in there, inventory, and describe, and that's our table. And that's all we still got to grant. So we've got the table, we've got a user. We must allow the user to access the table. And we're going to give it very limited, just select insert delete on that very specific table to the user we created. And now that's what our app is going to use, that username to access stuff. Now we'll exit. So the first thing we want to do then, now that we've got the skeleton app put together and we've got MySQL set up, we're going to set up the basic server. And we're going to have to use npm to install the Express packages. So install both work, and Express. And Express is the package that we're adding. It'll do a quick little add or install 7 package. So now we have a node modules directory, and that's the one that we don't want to add that. We don't want to commit that to Git, because inside the node module directory is all the packages that Express needs to run, including Express itself that we added. So there's Express. And if you take a look at the Express package.json, you'll see that it has all of the dependencies here that are now in that directory. And it's a nice thing that npm just kind of automatically installs all that for you. We're going to make a couple of changes to the package.json. The very first thing we're going to do is type module, and this makes it use the module system from ECMAScript instead of the default require system. And we're going to change the name. Okay, we already got main there. So in source, we're going to create a new file called app.js, and that is going to be the entry point for our program. And inside the app.js file, you need to import the stuff we just made. So we're going to import Express. It's just the package that we're going to use to manage it. Now, Express itself is not the web server. The web server is built into native node packages. Express just makes it a lot easier to use. We're going to need a port. So process.environment.port means if we set it in the environment variable, we'll use that. Barring that not existing, we'll use port 8000. The app is simply call the Express returns a function. We'll call that, and that constructs our app. In order to start the actual server, we'll use the app.listen. We'll put in our port number, a default IP number, and we'll just put up a little message saying that we've started our server. Now, the next part is not strictly required. I like to add it because sometimes it doesn't shut down very cleanly. So we're going to capture the signal, the interrupt and the termination signal, and we're going to call our own stop method. And instead of just exiting the process, we're going to also close the server, and this will stop the server from hanging and taking up our terminal. And that is it. That is how you start. That is core web server with Express. Of course, it doesn't do anything yet, but we'll take care of that in a minute. Go node dot will automatically run whatever is in your main. In your package.json is source.app.js, so it's running that. We could also strictly say node. Of course, source.app.js is the same thing. So let's still take a quick look at the server. So there's nothing there yet. So it says cannot get, but that's actually a sign that the server is running. If you get a 404 error, 404s are returned by the server, they're not by the browser. So that means our server indeed is running, but of course it's not doing anything yet. So let's fix that. So we're going to start our, the very first thing we want to do is we want to load any static web pages. So under here, if we create a file, we're just going to call it index.html. This is just a temporary file. That's going to, just to make sure that we can see that we're serving pages correctly. But we need to tell the app to do that. So we're going to add a function in here. We're going to call it load routes, and we're going to stick it right here. And now routes are things that tell the server where to find stuff, basically. And we are going to do first a load routes function here, and we're going to do and that is the to put the path in there as well. www path, and that should tell it to use the www directory as to serve files. So this is a function. And let's go run the server again, have a quick look, make sure everything is kosher. I am a file, so there it is, exists. by default, if you just go to the browser, it will also send the index.html file. And that's just something that most web browsers do. So there, now it's running, now it's serving files. However, our routes can we don't want to edit the app.js file every time we add a new route or update a route. And we're going to create a root subdirectory up here under source in order to manage our routes. So we'll create the first one, new file, we'll call it 300 static.js. Now we'll see what the numbers are for in just a minute. They're just to help organize the order of the files. But we're going to put everything that we just put in that function for loading routes into here. And we're going to export the return. So the export static.www path, and that's just what we just put in. You'll recognize from a second ago here. So instead of doing that, what we are going to do is we would go import. We're going to call it static root from /root from. And now we can just go down here and go app.use static root. Start the server. Make sure everything's kosher. Yeah, I'm a file. Make sure it serves something. No file, right? That doesn't exist. So we get to 404. However, what we would prefer to do, and we're going to do a little bit of Node.js magic here, and we are going to dynamically load the routes into there so that we don't actually have to update the main server file every time we want a new route. So in the app.js file, we're going to delete this. That's just, I just wanted to demonstrate how you do that. So instead of importing statically when we write the program, we're going to import dynamically when we run the program. So we're going to need two more packages here, and these don't need npm because FS, which stands for file system, is a native Node package, and so is path, which is for building URL path, or for building that file system paths. We're going to use those down here. So we will put in the directory. So we want source.roots is where we want it. If you want to override that, put it as an environment variable. If that path doesn't exist, let's not crash the server. Let's just return and not load any routes. And file system will read the contents of that directory and return all the file names. Now this sort here is what's sorting all of our routes alphabetically. So of course, that's why I put the number in front, so it goes in the exact order that we want, as certain routes, if they fire first, won't necessarily call the ones after it. So we're going to take, for every entry in the contents, that's for every file name, we're going to do something with. First of all, we need to build the full path. So entry only gives the actual relative file name to the path. So we have to add path to it. So those source roots, whatever the file name is, and also the current working directory so that we get an absolute path to it instead of a relative path. And that just keeps things cleaner. Now, as we import it statically above with the import statement, we can use the import function down below, but you'll notice that it's an asynchronous function or returns a promise. So we're going to have to make this function async in order to call the promise and just make that nice and easy to read if you've seen promises written out longhand. So what that will do is be the full path. We have the full path, absolute path to the entry. That loads the route. Now we got to give that route. That's the same as it takes whatever was returned by export default. And now we got to give that to the app. So app.use route. And that's the same as we did before, but now it's being done dynamically. So every time that we add a route to the routes directory, it will be loaded. And just for our benefit, we're just going to print out the full path of that so that when we load it, you will see the route that, so it's loaded the static route. And if we go back, take a look, yep, still exists. We're going to add a couple more routes here. We're going to add a log route. Now the log route we want to run first. So we're going to call it 100 log.js. It's going to be the same basic framework as the static route. So we go into import the Express package. We're going to create express.router to create the router. Export the router because that's what we need to load into the app dynamically that we just built. Now we're going to use a command called router.use. And that means this is the path that it's going to. This wraps it. We're going to call it explicitly with router.use. The first parameter is the URL that we want to catch. And we want to catch all URLs, so we're going to use a star. The second parameter is the middleware function. It's an anonymous function that takes a request, which is what the client says to you, a response object, which is how you write out to the client, and next. And next is the next piece of middleware in the chain. You may not all functions necessarily call next, so that's why you have to be kind of careful. And the order of your middleware. There we go. Make that look nice. And all we're going to do here is we're going to log out the method. So the request.method is your HTTP method that was sent. So that's your get, your post, your put, your deletes, stuff like that. And then the original URL is the URL that they have requested. We have to call next, or else nothing else in the chain is going to run. We'll call next, and the next one in this case will be static, and it'll serve the page. So we're just going to put the terminal over here and bring you up. Start the app again. And if we hit refresh, you'll see we've got a get. If we go get index, doesn't exist. We see a get index. .html file does exist, so it gets served. And that's this. And this is the usual state that I'm coding in, is usually terminal next to browser to click back and forth and make sure everything's running. And don't forget, we'll just stop the server because every time we make a change to it, we need to reload it. So now we've got the database, right? What we need to do is we want to make an interface to the database. And the reason we make an interface to the database is so that we can pull it out and put something else in. If you want to use a different database that has different commands, if you want to use a file system to store your data instead, then you don't have to rewrite the whole app and find every instance of it. We just have to rewrite the interface file. Oops. So we'll go with new folder, and we're going to call it model. And in model, we're going to create a file called db interface.js. There's nothing in it right now. What we want to do is, as we build this, because we don't have a server to test this on yet, because that's what we're building, we're going to create some tests for it. And we're just going to create a file down here. We're going to call it the same thing. This is your test files for your app. Now you can call it test interface, test DB interface. Should be something that lets you know that that's what we're testing. Now, of course, for the sake of expediency, I'm just going to do a lot of copying and pasting here. Oh, but first we need to add Mocha. So we're going to add PMI, and we're going to go with save dev. And that means we're saving this package as a development package and not as an installation package, because you don't need it to actually run the app. You just need it to build the app. So npmi Mocha. Mocha is our test bed that we're using. And you can run it with npx. npx stands for node package execute. If you npx Mocha, there's no test, so nothing's happening. Minus help will show you the parameters. But we're just going to go into here, and we're going to update this with Mocha. So that would be the same as typing npx Mocha. We'll go with npm run test, and it'll just run whatever's in our test script. So let's build some tests real quick. So we're going to kind of breakneck through this, but of course, at the end, I'll give you the GitHub repo, and then you can go back and look at this code on your own time, as this should really be more of a guide to the code as you're looking. So DB interface, so we need to import the interface, and we're going to use assert, which is a native library for running tests to assert something's correct. Mocha uses describe as their tag, so that's just a test group. We're going to call it data interface test. So we're testing the database interface. And the actual tests in Mocha are called it. So it's like it does something. In this case, it's just going to be it's a sanity test. And what we're going to do is we are going to open up the new DBI interface. connect to it and close it. So that implies that we need two functions right away. And because we're using new, it's going to be a class. So let's go in and just plug those in right now. So at the top, we need the libraries we're going to be using, MySQL and .env. So let's go import those. MySQL. Now we're using MySQL 2 because it's got built-in promises for you, which makes the code a lot easier to read. However, there is an output bug that is reporting lost packets that aren't actually lost. So just ignore those. And we're going to use a .env. Oh, sorry, npm i.env. And this is how we're going to read a .env file into our environment variable. So if you don't set them explicitly in your terminal, you can put them in an env file. So we're going to create a new file called .env. Now, because this is going to have mission critical information like passwords, we want to make sure that this does not go into our Git repository. So we're going to go with the .env there. And we'll just put our variables in there. And these are all stuff, as you'll recall, when we made our user, our SQL user, that was our user password, inventory user username, and of course the database that we're using is inventory. We haven't included the table name because typically you have multiple table names or multiple tables that you're using for an app. So you would put those into your code, hard code them in a config file. We're going to attach them to the inventory API, or there's a DB interface class. So first things first, it's a class we're using, export default DB interface. We'll put that in now so we don't forget it. And we are going to create a static getter. This is just for the inventory. That's our table name. We're going to put that there. The same as the database name, and there's only one, so it's fairly straightforward. And we're going to put in the connect function. So what's going on here? It's asynchronous because that's why we're using MySQL 2, the promise library. The host is not going to change. It's localhost. That should probably go in a config file, but we'll just leave that hard-coded. And there, this is process.env. So we actually have to load the file into it. So it's .env.config, and it'll automatically look for the .env file and load those into your process.environment variables, which of course will also contain all of the environment variables that your environment is set. So these will match up with down here with the SQL PW, SQL user, and SQL DB that we're going to use in order to connect to our database. As you'll have noted, we had a close, and close is fairly straightforward. We'll go this.connection.close. That's because we saved the created connection to something called this.connection. And that should be enough to do a test. So we're going to go npx mocha to test it. Oh, we got a problem. Could not find module DB interface imported. What did I do incorrect there? Source model DB interface. I often, interface. There you go. And this right there is a good example of why we test our files. Interface. It's just to get rid of those little errors that you're not going to catch by staring at it. There we go. One passing test. So now what we're going to do is we're going to go through, we're going to build all of the tests with a quick explanation of what we're doing or why we're building those tests. And we will try to get through this quickly because of our time constraints. So the first thing we're going to do is it creates a record. Asynchronous function, call the DBI new DBI interface, connect, the same as all the stuff above, except now we're adding a new create record function. And it should return an ID and accept 3 parameters, which you'll recognize as the stuff that we set up the SQL table as: description, quantity, and price. So in DB interface, we are going to do the create record. We're going to stop and talk about this one ever so briefly because there's an important distinction here. While the function itself is very simple looking, it's just 3 lines, and I think all of them are 3 or 4 lines. What you want to know is we put the constant query, make a string because they tend to get pretty long. I'll put it on its own line. Well, we use string interpolation, which is injecting a value into the string. Here, we don't use string interpolation for the values, as you'll recognize from your MySQL classes. You need to put in actual string values, but that is potential injection attack if you just put in a string interpolation. So whatever the user puts in, they can do something to you. So instead, we're going to use the execute, and we're going to use these parameters. And these parameters will put in description, quantity, and price into these question mark placeholders. But what it'll also do is it'll surround them with quotes and escape any special characters, which is going to help prevent some injection attacks. Now, of course, we're going to return response.insert ID. That's the generated primary key. And we were just for your sake, we're going to console.log the response so that you can see what the database MySQL library is actually returning. So let's run the next test, npx mocha. 2 tests passing, that's good. And this is what it returned to us. It returned to us a result set header, affected rows, that's how many rows were inserted. And that is the ID that it assigned it. So that's what we really care about. And that's how we're going to reference back to our records in the future. We'll just get rid of this console.log. And let's add the next test. And the next test is list records. So if you add a record, you want to be able to see what you've added. Go back to the test. We do the same thing. We're going to create 2 records, and then we're going to make sure that if we list the records, it has a records.length of 2, implying that our return value is an array with a length. This is going to be an even simpler method. Try and keep these methods simple. They're easy to read, easy to debug, right? So we're going to use a select. From the table, from the database name. There are no parameters to it, so we're not worried about that. It is just a strict and simple SQL call. And then we'll do the test. Oh, we've got a problem. DBI clear table. Oh, I forgot. So in our test, we have to clear the table every time, just so it has right length and stuff. So we'll go build that method now. And that's just to remove all records from the table. And this is one of, typically you don't want to include test methods or methods that are for your testing, because we're not going to expose this method to the end user, also just erase their table. But we do need to clear it out for testing, so we are going to make it. And this is a simple delete SQL delete function. Here we go. We'll just put that after list. And this is delete from database table. And that will remove all of your records. Now, reduce the font a little bit on this guy. There we go. So we got 3 running. Of course, this is the warning I was talking about. Yes, we received all 10 packets. For some reason, it thinks we didn't receive any. And now the next part of the test is retrieve a record. So we put in a record, we've listed the records, and now we are going to retrieve a record. Much in the same way, it's we got list records, we're going to have a retrieve record, and it should retrieve a single record that has the values that we inserted. Retrieve record. There we go. Now this one is also going to have a parameter because we have to pass in the ID. So the ID that we got back before, we'll pass in again parameterized and passed in as an array of values, in this case, 1 value. And again, for your benefit, we're going to log that response just so you can see what it is. And I'm going to log the response from list records because I forgot to do that one to show you. So you run the test again. Oh, who is RES? Why is that not? And if you want to know what's, if ever you're using Mocha and you want to know which test it failed on, we go with bail, so it'll stop. So it failed on list records. Rows. It's not called response, it's called rows in this case. That's why. There, they all work this time. So listing will return an array of all records. In this case, apple and banana. In this case down here, we return one record. Now it's actually an array of records again, but because there's one ID per record, the array is always going to be a length of 1. Up here, so now for setting, we need to be able to update our records as well. And we're going to use 3 methods for that, but they're all basically the same method. And it's going to be description, quantity, and price. And what we will do is we'll have a method called set price, set quantity, and set description. And they're all going to be the same thing with a slight change on what column we're changing. I'll stick that right there. So set, so update is the command that the SQL command. Set the column name to a value, parameterized, where ID, parameterized, and passed in as an array. But you'll notice that we've only passed in value and ID. We hard code in the field name, the column name. And we just change that. So description, quantity, price, each one's that, and it will update. It must exist, of course, first. But we will create them and test it. And there we go. 7 passing. That's good. Our final test is, of course, we want to be able to delete records that we've added, doing all the same thing. You'll notice that all of these tests, and even when I make them, I usually literally copy the previous test and just change a few lines, because a lot of this is very boilerplate. But what's different here, we create the record, but we also want to delete the record. And because we clear the table before we create and delete it, there should be no records in the table. So we'll assert that records.length is equal to 0 to create the delete record. Delete is the function that we are using, except that as before we just deleted from table, deletes everything. We are going to specify an ID, and that will tell us which one to delete. So there we go, 8 passing tests. And now we've built the database interface. So long as you create another file that has all the exact same methods as we've put here, you can replace this file with any interface that you like. It can be a database, it can be a file system, so on and so forth. The last thing we need to create a root that will access it. So the root doesn't actually care that it's a database. It just cares that it gets a method with these, it gets a class with these methods. So we're going to create a root now. New file, we're going to call this 200.api.inventory.js. The API is not required, to call it whatever you want. I like the API in there, so I know that this is the API interface. Now, we've still got the problem of chicken and the egg here, that we don't have a web app in order to test our API. So we're going to use something here, but I guess we're putting the cart before the horse. We got to build something to test. So we're going to import Express, and we're going to import the DB interface that we just built. Of course, we are going to create the router, create a DBI database interface, and we're going to connect to it. Not necessarily the best practice to leave the connection open like that, but this is just for testing. You could open up the connection and close it for every request if you like. So the very first thing we're going to do is, again, this is also very boilerplate. It's a lot of the same stuff over and over again. But this is our router. You'll recognize the router from log and static. The URL is the first parameter we use. Now this is what we've called it. So API inventory is where our API resides. That is going to be the address we put into our browser to get to it. This express.url encoded is middleware that pulls information out of a form, out of an HTML form, and puts it into the request.body field. Asynchronous with the middleware that we build is going to have 3 lines. First one is we create a record. So you recognize this as what we just built with the database interface and tested, and putting in the 3 values that get passed in by the HTML form. Response.write is going to write out, that's the response that is getting physically sent to the client. It handles all the headers. You can modify the headers as you like, but we're not going to do that in this case. We're just going to put the body to stringify, means take an object and turn it into a string, a JSON, a valid JSON string. and use response.end to end the communication and actually send it to the user. Note that we're not calling next because this will be the endpoint in the chain. It'll go log and then it'll go the inventory, and that's it. We're not actually calling any static files. However, so we've got this written. How do we make sure it works? We're going to use something, and I'm just going to quickly introduce it here. You can look it up on your own time, and it is called Postman. And Postman lets you connect to a running API and make sure it works the way you expect it to. So we're going to go node dot. Oh, we got an app.use requires a middleware function. That is, let's go fix that error. One of the problems with dynamically loading these is you don't get necessarily the best error messages. We forgot to return. Export default, because we import, we need to export default router. To export the router to import the router, right? There we go. Okay, so now we are loading up the API inventory router. We're going to go over to Postman, and now we've already built the first one we built was post, which is create a record. And in here are the fields. So we've clicked on body, and we've clicked on www form URL encoded, and that is the default encoding for HTML forms, and that is what we're going to use to put values in. So we just go. I've pre-built this for expediency. So we click on send. It will send the request, and the request back says we put ID 41. So we've got 41 records in there. You want to put, we're going to put a different one in here. We'll go pair and send another one, ID 42. So that's a new record as we put in with ID of 42. Now we're going to go in and we're going to create the interface to the rest of them, and we'll just show you kind of a back and forth on how they run. Let's, where are we? Okay. Now, for the sake of expediency, I'm just going to bring these all in and have a quick talk about them. So, got post. So notice that post, before we use, post is the HTTP method that it's reading. So in post here, when we sent it, post, we selected post, but there's also get, put, delete. There's a whole bunch of them. And each one of them corresponds to some sort of semantic meaning. The second one is get. So this is going to retrieve a single record that we put in. And a particular note here that is different from what we did above is we've added a parameter to the URL. And this is just an Express thing. What it will do is it will say, we'll take the URL and whatever is there, we will put in the request.params.id field, right? Like if you called IDS, then this would be IDS and so on and so forth. And that allows us to know what record we are referring to. So that is the get. So we get a record, you send it. So there's no parameters, there's nothing to send on the body. It's just the URL 41. Oh, of course, when you update your server, you have to reload it. And there you go. And it returns an array, of course, has one value of 41. If you want to do 42, which should be the second thing we did with pair. If it doesn't exist, we get an empty array. It just returns an empty array. You can check for that if you like, to ensure that you got something. If you want to list all records, note that it's also a get function, but without the ID. Get all records, send, and then we get an array of the records. So we've only got 2 in there. And there we go. Same thing, delete. You can test it and you go back and you get all records. There should be one less because we've called the delete. And then update. Now update, as you'll note, we used JSON instead of XML URL, www form URL encoded. So we go raw and just select JSON over here. We're going to change number 41 so that the field description says papaya. I don't have a response on that one, but we'll just get everything. Oh, I guess we don't have a 41 anymore, do we? So let's change that to 42. Send, get all records. There it is. So now it's papaya. All right, so now we have an API and deployed. What we don't have is a way of looking at the API or of the user of looking at the API. And that is the second part. Let's see if I can build this in the next 13 minutes. So we're going to be putting this in the www subdirectory, which is your public client-side subdirectory. We'll get rid of our index.html file that was just there for testing. And we're going to create a couple of subdirectories or folders in here. So the first one is view. And view is just a word. It means like landing page, where we're going to starting points for users. And we're just going to go view index, and we're only going to have that one. We are going to create a model subdirectory, and this is going to be the interface, the client-side interface to the DB interface file that we made before. Not new file, new folder, and we're going to shared SCSS. That's just, even though we only have one view, I like to put all shared style sheets into their own subdirectory as opposed to in the view. So now I'm going to just copy these files over, these SCSS files. So we're going to put a couple of shared SCSS. That's just a border. It's got a parameter. This is something that SCSS does, or SASS, but not raw CSS files. And that's one of the benefits of using them. We've got an include up there. And then, of course, we need an SCSS file for our index. I'm going to go put that in the view index directory called SCSS. And this is the important thing that we're really using SCSS for, is the imports, just so we can divide up and reuse code. Kind of critical. However, to use SCSS, we need a package. So npm I SCSS. SCSS and SCSS are very similar. SCSS compiles both. And now we've got that. If we want to call it, we are going to put in, because they can be quite long, these little SCSS commands, we're going to put it in the package.json script over here. So we've got test already, and we've got, we're going to go build style and watch style. Build style will build it once, and watch style will wait for a change and then update every time on a loop. You've got the input directory SCSS, the output directory CSS, and let's run that now. So we go npm run build style. Did I save it? Probably didn't save it. Let's save that. Makes every difference in the world. And it runs it. If we take a look over here, where it used to be just SCSS, there's now CSS and CSS map. You can add those to your get ignore if you like, but you don't have to. These are what will actually get served to the user. Now, I'd mentioned before that we're going to use EJS. And now in this demonstration, we're only using embedded JavaScript, is what EJS stands for, in order to save the file, in order to include files into it and make it a lot easier to read your HTML. It's not strictly necessary. So we will npm I EJS to install the package. We will go up to our app. Now we have to specify what and that what the view renderer is. So Express can handle view renderers, which is what this is called. You just have to do some settings for it. So right before we load the roots, set views. So our views will be in www view. You'll notice, remember, from down there. And the view engine is EJS. So that's what's doing the rendering. We are also going to add a root, a new file. We're going to call it 300 view.index.js. And I like to build one of these for every landing page, unless you have like a lot of our landing pages. And this will get called when you call to the index. Now you notice that we didn't use, so we use here instead of an actual HTTP protocol or method. And we use for the URL index. And that means that it's going to be our server name /index, not /view/index/index.ejs. And it just makes it a lot easier to print out or give people your URL. Response.render is your rendering engine that we just set in app.js. We told it to use the EJS rendering engine. The actual starting page is index.ejs. We haven't made it yet. We can just build one right now. New file, index.ejs. You'll notice that it gives a little brackets there on our Visual Studio Code. And that's just to indicate that in reality, it's an HTML file that's being rendered. What happens is, so note that this is not asynchronous, so we don't use the await async. keywords, and instead we pass it a callback function that calls it with error in HTML. If there's an error, you'll handle it somehow. If there's not an error, we're just going to return the HTML. So the HTML is the rendered HTML from the EJS rendering engine. Now that seems, it's not particularly difficult to set up, and there's a lot more power than what we're going to use for it here. But if you're familiar with HTML, what you'll recognize is these aren't HTML. That's an HTML comment. That's an EJS for including other pages. And I like to do that to make things a bit more readable. So it's in partials. Just by convention, we call it a new folder called partials. Call it what you want. It stands for partial view. And we're going to put 2 files in there. And we'll look at those momentarily. So we got 2 files. This first one is a form, and the second one is just some divs that I've set up myself. And that's the reason, is you'll remember that we did the XML, the URL encoded versus the JSON encoded. And that's just 2 different ways of sending things out. Also take note that there's an extra iframe in here, and that if you do a post, it's going to open up a new browser window to show the response. And what you can do to override that is you can set the target to an iframe and just handle an update and do what you want with it. That way it's not opening up a new page. We did with shrink hide there because we don't want the iframe on our page. We don't want people to see it. So the shrink hide is just top over off the screen, left off the screen, and width as small as you can go. I believe you can't go with 0 pixels or else it won't actually render it. And you want it to render so that you can catch the response. Create new index. We've also got a script subdirectory we're going to put in here, new file, new folder, scripts. And in here, you'll notice we got the index.mjs script. We're going to build that now. New file, index.mjs. And that's your JavaScript. That'll get called, and we're going to populate that in a moment. Let's run our server, make sure everything's kosher. Node dot. It's not index.html because we gave it, remember we gave it the path of, just index. And there we go. So that's the form. Of course, it doesn't do anything yet because it's just view, right? We haven't set up the functionality, the controlling part. But before we set up the controlling, we want to quickly put in the interface to the, I created something called, we're going to delete that. That's supposed to be a subdirectory, not a file. Okay, so create a subdirectory called model. And in there, we're going to create a model. We're just going to call it inventory API because it's the interface to our inventory API. And let's have a real quick look through this. You'll notice that there's methods. The encoding type for this, that's listing. So there's no encoding type because we don't say anything. So when we set up our CRUD, we originally said the method, get, post, delete. And these all correspond to get, put, delete, and so on and so forth. And post, there's the post. And this is the client side communication. Now you'll notice we use fetch and the URL is the first argument. You can add information. So the method, these are like header information and stuff. Get. Now down here, we added headers for the content type to application JSON. So you'll recall that when we did the update method, we're actually passing a JSON object as opposed to form parameters along, and it's a put. And when you have to specify the body, we'll stringify the data being an object up here with the 2 values that we want. So when we go add record, you'll take a particular note. Actually, there was no add record in here. And the reason there's no add record in here is we don't need an interface with fetch because the form will do it for you. Now, you typically would not do both in one app, try and stick to one method or the other. I've done it for the sake of demonstration so that you have both. Now, this is again an order of files thing. So we're kind of got to build up the files. When I do this, this usually doesn't, you don't squeeze it into an hour. You'll build it piecemeal, but let's, I'm just going to copy my scripts over here. So we've got index.ejs, MJS. Oh, that's not supposed to be there. You go away. So the first one we want to is load select. So what is going on here is this is a function that is going to load the values into your selector. So you've got this up here. It's currently empty, nothing there. We want to put values into it, but we want to put values into it dynamically. We don't know ahead of time what they are. It's whatever it's in the database. So we're going to just pass in the data. It's going to be some array. That's the result from the database. Our description field. And we'll select the element. Record list is the name of the selector that we are doing. So this is under list. Oh, sorry. Under partials, try and name them the same. We just change the extension here. List up top is select. The idea of it is record list. Replace children erases all the children. For each value of record in data, what we'll do is we'll create a new element, a new option element. We're going to record the value on that element of the data, the returned ID from the SQL query. And then we will set the description to the inner HTML, so it shows you what it is, and then we append it to element, select element, which is our record list. In order to call that, so we export it as load select in list records. It is simply called, we add, so looking at everything down here first, which we'll get to. This is our form record list. So this is the function that we export and then load into index.html. Which we'll have to do that in a moment. And all it is doing is it calls the inventory API list records, calls the load select method that we just built to load those methods into there and populate the selector. What we need to do is call this method from main. So index.mjs, which is specified by convention, you just call it the same name as the file or index being the start. It's actually specified right here. So view index, right here, view index scripts. Index.mjs is your entry point for that. So we're going to import the two files here that we just added. The one we just looked at was form list, and of course, call the functions that are returned from. We shouldn't have to restart the server now because everything's client side. Refresh, haha. So we've only got one value in there. Let's take a quick look at that value so you can see what I was talking about earlier. This is a select object. I don't think I can zoom in. A select object, and I added the option element, HTML element, and set the data ID to it. And what that means is that I can now retrieve that ID if I want to select, if I want to delete or update it, so on and so forth. By convention, any user specified attributes on an HTML element should have preceded the data dash. So it's ID, data dash ID, or data dash something. That's just a convention. So if we select that, it now loads into these values. What is actually going on? We're going to have a quick look back to there. What we did is we click the select button, which is here. So two buttons, ID select in the list records. So we add click listeners to it and call click select, click delete. And those are down here. Now we use the inventory API to retrieve the record and we get ID. Well, what's ID? Well, as I mentioned, it's embedded, the ID is embedded on the HTML element. So you have to get the selected element from record list, which is the selector, the name of it, get the index of the currently selected element, retrieve it from its child nodes, and then retrieve the attribute. And because that's 4 lines and kind of mucky, I put that in a function. And that is simply saying, get the ID attribute. Call it from retrieve records to retrieve that record. If there, remember, it's an array that we return, so we return a 0 length array for failure. So test for the length of less than 1. If it's 0, it doesn't exist. And then we just simply take the information from the records, first record or 0 indexed, and plug that in to the fields. So we do query selector to get the actual text field and set the inner HTML to it. Delete is very similar in that we get the ID, except that there's no fields to fill in. After we do a delete, we like to reload the list because it's changed and it will no longer exist. So if you take a look there, we've selected papaya, delete it, it's gone. We don't want to have to refresh the browser every time you change your list. Now, adding an item, we're going to add apple, 1 apple, an expensive apple, and submit. Now, it's updated as well, and you can guess how we've done that. Select now does that, and of course, delete. However, you'll recall that we did not write an inventory API for add record. And that is because in form add record, you'll notice that we have a form. So again, that's going to handle the fetch for you. But it sends a response that we want to say, hey, once you're done, you can't just refresh the screen right away or refresh your selector right away, because it takes time for the communication to go back and forth and for the database to actually update the value. So what we do is on hidden frame, under form add record script, we take the hidden frame and we add a load event listener. So what happens is that the HTML form will send its response to hidden frame. And when we notice that a load has occurred, we know it's done and the values in there we can handle. Of course, we're not doing anything with the value in there, but we are refreshing the load select there. So I do believe that is the end of the app development portion. We'll just quickly take a look at that. You do that again, you got 2 apples, update to pair, update, and there you go. And that is deployment of an app in 1 hour.